All right, so the two examples we're going to look at today. One is really just kind of story problems of the skill we learned yesterday, finding a vertex. These ones aren't going to be too bad. And the second example is about what's called a quadratic regression, and that's done with has to be done with some sort of calculator. So we'll get to that. All right, so it says we have this graph over here. So equation makes a graph. It says it shows the profit that a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? So what this shows is based off however they change their selling price. And this is actually a very legit thing, because if you sell something really cheap, more people buy it, but you make less money. And if you sell something for a really expensive price, less people buy it, but they're worth more. So what there is for pretty much anything that you sell, there's like a perfect price to sell it at, where the price is cheap enough where a lot of people buy it and it kind of maximizes your profit. So companies that set price points on things and stores that sell things, they develop these equations. They develop about like big sets of data and surveys and stuff like that. But this is a very legit thing where they create a graph that models the scenario. And they could look at it and be like, okay, if we sold this for this amount, this is where we're going to maximize our profit. We're going to get the most profit if we sell it for this amount. And so this is kind of what today's about, is these projection type equations. So right now we don't know where this equation came from. We just know that that is the equation that models the price. Now, you could visually look at this and say, what's the maximum profit? You could be like, I don't know, probably about $6,500, something like that. And what are they going to sell it for? Something like maybe $37, $36. We can't see it exactly though. So to get the exact answer, we can just use our skill from yesterday, which is find the coordinate of the vertex, because this is the vertex right here. So we go ahead and use our formula to find the h and the k values. So our h is that negative b over 2a formula. That's going to give us these specific values that we can't just see directly from the graph. So if we go back to our problem here, a is negative 10 and b is 700. That's what we're going to use when we work this out. So if b is 700, we'll have negative 700 over 2 times the negative 10. So that's negative 700 divided by negative 20, which is going to just be 35. So, all right, so that's our x, or our h value, our x value, whatever we want to say. So as we're going to write what the coordinate of this is, we know it's at 35 comma something. And then we can find that something by just substituting 35 into the problem. And this is one I would recommend using your calculator for, because it's big numbers. So I'll just type it in. And when you're typing something like this in, use parentheses. So when you type in, 35, put it with parentheses, plus 700 times 35, and then minus the 6,000. And then that should give us our value. And the answer should make sense. So I got 6,250. 6,250. So if you remember when we looked at this and I was kind of trying to estimate, I said, it was at maybe 36. It was actually at 35. And I said maybe it was at about 6,500. It was at 6,250. So this answer completely makes sense, and everything fits as far as what's going on there. So now we just got to make sure we actually answer the question. It says, what's the maximum profit they can expect to earn? That answer would be $6,250. That's the highest that this graph ever reaches. Okay? So that's just putting what we learned yesterday to a story scenario type problem. Now, I do want to show you one other thing that you might find useful, or you may not find useful. Maybe not so much on this problem, but on future ones, is you can do this type of stuff in a graphing calculator or on the apps and stuff like that as well. If we put this in our y equals, so I'm going to go ahead and do this, and I'll show you kind of how this works if you want to see it, because it's a handy move to know. So if I put this in, whoops, we got two x's, don't I? X squared. Actually, I guess that would work. But anyway, the minus 6,000. All right, so if I get my equation in there, if I press graph, this is obviously going to be nowhere on my grid because, it's already changed it. Sorry. Pretend that didn't happen. I guess I did this the other day. So if I graph it on the normal standard window, I'm pretty much going to see nothing, or maybe just a little tiny. I can see a little tiny bit of this graph, and that's because this graph doesn't really start until about 10. So I'm seeing this little part of the graph right here, but that obviously isn't very helpful to me. So you could sit here and you could click zoom out and zoom out and zoom out forever. But what actually is the better option here, and this is what I kind of wanted to show you, is you can just change the window. So if you've ever seen it before, there's this button on here that says window. If you press window, that lets you change what this graph goes by. So right now, this graph goes, on my x's, it goes from negative 10 to 10 by ones. And on my y's, it goes from negative 10 to 10 by ones. Don't worry about this x res. That's not important for right now. But this is telling you what are the highest, lowest x values. And what is every tick mark's at 1. So if I change these, how do I know what to change them to? Well, I know because I look at this graph. But if I make my x's go from 0 to 80 and my y's go from 0 to 8,000, this graph's going to look identical. So I'm just going to show you that. So if I say x min at 0, x max at 80, so that'll match the graph there. Y min at 0, y max at 8,000. That's going to make my graph on here basically exactly match this because I'm setting it to the same scale. So if I do that and I press graph, you'll see this should look really similar to the one on the paper, which is pretty cool. And so using your window there, if you kind of have an idea of what sort of domain and range you're looking at, you can go to the window and you can just set it there versus pressing zoom in, zoom out, that kind of stuff. So if you didn't know about that, that is a pretty useful thing. But again, how does that help us find the answer? It doesn't yet. But now that we can see this point, we can actually have this calculator find that value for us. So instead of going through the equation, you can have it, and it's in that same menu we've used before, this calc menu. So if you go second trace, our graph has a maximum point. It's the highest point. If you want to know that maximum point and you pick maximum, so I'm going to do that, it's going to ask you 3 questions here. Now, these actually are important. They're going to say left bound, right bound, and guess. So we know that maximum point is somewhere like right up here. So when they say left bound, you have to make your cursor somewhere to the left of that maximum. So if I put it over here and I press enter, now you'll notice it now says right bound. So now I need to put it somewhere to the right of the maximum. Then I press enter, and it'll now say guess. What I'm telling my calculator to do here is I'm saying, hey, look between these 2 values and tell me the highest value that's in there. Tell me the maximum value. So now if I press guess, it should give me the same answer that I got. And it does. It says 35.9999, which is, or 34.99, that is 35. And then the 6250. So you can actually do it in the calculator also. This problem, I don't think it's super difficult to do that on, but it's a useful skill to know. It's something that you can have this calculator find min and max values or coordinates by just a few button presses. So I like to show it to you. Obviously, this did the exact same thing, but I think it's really useful to have different ways to do the same thing. It's ways to check your answers. It's ways to do stuff. So I like to show that stuff when it's applicable here. All right, so there's a problem right below here that's kind of the same scenario. It's about a water balloon being thrown out of a window, but it gives you an equation and asks for the maximum height. So take a second here and see if you can figure this one out. Try to get that coordinate, get that max height, and see what you get. Okay, so just going to talk kind of briefly here. So I already did the algebraic way of doing this problem. I found the h value to be 5. I substitute the 5 in to find that the k value is 450. And that's actually the answer to my problem. Because the problem is, what's the maximum height of the water balloon after it's thrown? The max height's going to happen right here. 450 definitely makes sense as the answer. It looks like it's graphically correct. So yeah, 450 feet. Again, it can all be checked graphing in your calculator also. So I put it in just to see it. There we go. If I graph it, I'm still on my funky window, so it shows it really tiny here. But I could adjust the window exactly like we did before. If I go, 0 to 10, 0 to 12, there you can see that. And then I go, my max height there goes up to about 600 or 500 is going to be fine either way. But I should be able to graph it, see the same kind of thing. And I could do my finding the maximum coordinate on here again, just so you can see it. Find your max. Make sure you go to the left of the maximum, press enter. Go to the right of the maximum, press enter, and then put it somewhere nearby for guess. And we should get the same thing. Yeah, 5, 450. So again, just different ways of doing the same thing, and it's nice ways to be able to check your answers. Got any issues, questions, anything with this so far? All right, now the last thing we're going to look at today is what's called quadratic regression. So I'm going to just write that up here because that's what this is called. So it's called quadratic regression. So what this problem is it says, what is the equation of a parabola that passes through those 3 points? Now, none of those points are the vertex. If they told us one of those was the vertex, then we could just do what we've learned before, where we'd like, if this was the vertex, you could be like, okay, this is h and k. This could be x and y. I could solve for my a. I could come up with the equation. We've done that before. But this is just saying, hey, here's 3 points that are on this parabola. None of them necessarily are the vertex. What can you do? So the answer is actually, that'd be incredibly difficult to calculate. There's not an easy way to do that at all. If you don't know where the vertex is and you just know 3 random points, you plot them and you can't tell if it's supposed to go up or supposed to go down through them. There's not actually a good way to do it. So what there is there's a program that's written called a regression program. And it fits a line of best fit to this. You've probably done it with linear before, where you plot a bunch of stuff on a scatter plot and you find the line of best fit. You probably have done that in Algebra 1. This is doing the same thing, but instead of a straight line of best fit, this fits a U-shaped line of best fit. So this is some steps in the calculator. So I'm going to write these out for you, and then we're going to actually do it. So in the calculator, what I always recommend doing, because if any of your settings are weird, it's funky. So you should do a reset, which is always the same thing. It's second plus 7, 1, 2. So that resets your calculator, gets everything back to normal whatevers. So I'm just going to write everything out, then we'll do it. The next thing we need to do is we have to turn diagnostic on. So diagnostic on. And the way you do that is second, 0. Then you're going to pick the diagnostic on button and press enter. From there, we're going to press the stat key. And we're going to pick the edit option. For there, we're going to enter coordinates. So we're going to enter coordinates into L1 and L2. That's just list 1 and list 2. So it's like a little L sub 1, L sub 2. And then once we've done that, we press stat again. We go over to the calc option, and we pick the one that's called quad reg. So those are all your steps. Again, these are, as always, when we do these calculator steps, the steps written out always look kind of confusing. Once this one is saying, once you've done it a few times, it is actually, this is easier than like the matrix or any of the other stuff. It's actually less stuff to do. So we're gonna go ahead and do this for this problem. So I'm gonna start off with just the reset, like I said. So that's second plus 7, 1, 2. That gets everything out of your calculator. Any weird settings, any whatevers you had on there, gets you back to normal. And then the next thing we need to do is turn this diagnostic on. This is going to give us the information that we need for the problem. So that is second 0. Now, if you don't know anything about second 0 is what's called the catalog. It actually is everything that's in your calculator all in one spot. So if you ever forget where something is, like you forgot where absolute value is, you can actually go to the catalog. This is just an alphabetic list of literally everything that's in the calculator. So if you ever forget where something is, the catalog is kind of handy for that. We want the option called diagnostic on. The way you actually do this in the calculator is you got to press like 10 things. It's a really pain to find. So it's actually easier to find in the catalog. So we go to diagnostic on. You can also just press a letter. Like if you wanted to jump to a certain letter, like if I press O or if I press N or if I press whatever, it'll jump to that letter. G for garbage collect. But if you press D, it'll jump to D so you can save yourself a little time of scrolling there. But we want diagnostic on. So we pick that, press enter. And then when you're here, make sure you press enter so it says done. That means it's actually done that. It's actually turned your diagnostic on. That's what you have to have on for this program to work. But the default is it sets it off. So that's why if you do a reset, you need to turn it on. All right, now we're at the point where we're ready to work. So you only need to do this once. You don't have to do this every single time. But every time you grab a calculator, you do need to make sure this is on because the default setting when you reset it is it does shut it off. All right, so now we press stat, which is dead center right here below delete. You're going to pick the edit option. And what you should have here are a bunch of lists. Now, your coordinates are going to go into here. Now, it's going to be like x, y, x, y, x, y. So this is where we're going to type in those 3 coordinates. So we've got -2 and 32. We've got 1 and 5. And I just use enter in my arrow keys to move around here. And 3, 17. So your x's should go in one column, your y's should go in the other. So it basically just looks like a table of data. All right, I'm going to stop this because I got to make a part 2.